So the last part of this section, section 2.2, we're going to talk about different types of sets. Okay, so we've already talked about the empty set. That's the set with nothing in it, right? There's nothing in it. We also have finite sets. So that is a set that actually eventually ends. So here's an example. The number of ferrets in Spartanburg County, that is finite. You can count them, 265. Okay. No, I don't know how many ferrets are in Spartanburg County. But anyway, okay. An infinite set is a set that never ends. It goes on forever and ever and ever. So our counting numbers, that would be an infinite set. Okay. All right. We also have what's called the universal set. The universal set is the set of all the elements that are being discussed. So if we are talking about people that live in South Carolina, then the universal set would be the set of everybody living in South Carolina. Okay. If we were just talking about women that lived in Spartanburg, was our conversation, then the universal set would just be females in Spartanburg County. So the universal set depends on what you are talking about. Okay. The complement of the set is the set of all elements that's in the universal set, but is not in I think it helps if you see a picture. Okay, but the way you note a complement is you either put that little apostrophe after it or you put a bar over it. Okay, and this is a way you say it's an element of the sorry about that. It's an element of the universal set, but it's not part of A. So here we go. So let's let you be all of the college students. So this is you, all college students. Okay, so A is those that are married. Notice they're college students, but they are married. So the complement would be what? The complement a that would be or would be not married students. That makes sense. So they're in. They are actually They are in the universal set, so they are college students, but they are not part of whatever that is. Okay, so not married college students would be our complement of married college students. Okay, all right, so now let's talk about two more definitions. One is called the proper subset. Now, the proper subset, let's look at what it means, okay? Every element in set B, so see, there's set B. Every element in set B is an element of A. And this is the key. There is at least one element that is not in B. So you have a point P that is in A, but it's not in B. So this is called a proper subset. B is called a proper subset. Okay, here's the geeky way you say it. B is a proper subset of A if you have that little subset sign. That's what B means. B is a subset of A if and only if B is an element of A, but it's not equal to A. Okay, so this guy, all of them that are in B is also in A, but it's not equal to it because you've got this extra one out here. You've got this point P out there. Okay. All right. Now a subset. A subset is the whole set. Also a subset of this set. What in the world? Okay. So all this says is you do not have to have, doesn't have to have a point P in there that is not an element. In other words, it could be equal. Okay. Notice how I Note the difference between a proper subset and a subset. A subset, you see how it has this equal mark underneath it? Okay, so that means it could also be equal to A. So that's called a subset if and only if the element of B is an element of A. Okay, so when I think of a subset, in my mind, I'm thinking of a proper subset. I think a subset is something that there's got to be something in it that is not an element of the biggest, of the big set, okay? But that is actually called a proper subset, okay? So here's two weird features about it. The empty set is a subset of every set. So it's a subset of every set. So if you take everything out of it, out of a set, then you have the empty set. Okay. The whole set is also a subset of the set. That's what makes it a subset and not a proper subset. Miss Kitts, you were getting too geeky for me. Let's do an example. Now you know why we took a break before I started this one. Okay. So we're going to name all the proper subsets of D. Okay, so you could have, here they are, you could have A, you could have B. You also must have the empty set. That has to be in every set. Okay, so notice that with this one, is there something that was in D that is not in this set? B. So my B is this point, right? It's that one thing that's in there that's in the big one, but it's not in the proper subset. Okay, so here's B. So B is a proper subset because it's missing that A. And then you have the empty set that has to be in all of them. Okay, so now we're going to name the subsets. Notice it didn't say proper. Okay, so the subsets are going to have all of these guys. All of those are considered subsets, but it also includes something else. What is in this group in the subset that is not in the proper subset? Which one was added in example 2? The one that has everything in it. Okay? So that's the difference between a proper subset and just a regular old subset. Okay? The proper does not have this guy, the whole set in it. Okay. All right. And that's the end of this section. We only have one more section to complete in chapter 2.